exciting to see a room full of people at 6 o'clock on a weeknight to talk about functional programming. So this is my first time I've done a presentation like this in one of these settings, and so far I think it's going really well. So please interrupt me at any point if I say something wrong or if you have questions. I'll do my best to answer them. I describe myself as a tentative yellow belt at F# right now. Being generous. Started learning a couple weeks ago. So this will be fun for all of us. Who in here has used F#? I'm going to assume most people in here know C#. Just saying that moving forward, maybe a little bit of Python. So I want to start with a gentle introduction to F# syntax and what it kind of looks like, and then we're going to go into a live coding demo, and hopefully that'll go okay, in which I'm going to program an application to play Blackjack. Can everyone read that? Okay. So functional programming is very different than a lot of traditional programming models that you may see in a language like C# or like Python. We would consider those languages to be imperative, and how those operate is they change the program's state, and it's a sequence of steps, and everything's kind of dependent on those steps and assignments. Functional is totally different because everything is immutable, and everything's a function, and so everything is just composing functions with immutable data. So my definition is a paradigm of programming using expressions and functions without mutating state and data. Programs are constructed by applying and composing functions. Hopefully that will make sense as we get a little bit more into the code. In an abstract way, it's a little bit hard to grasp. So I would like to start first with talking about the let binding. And I'm going to be running all of this in something called F# interactive. So it's a .fsx script. It's not a .fs or a F# file, so I don't have to run the .NET run and do a compile and all that. It just is a lot faster in a setting like this. When you assign a variable, it is not really the same as C# because it's more associating a value with a name. So if I run, and you can see in this, the type is int, because F# has type inference. And F# is part of the .NET ecosystem, so it has access to all the .NET primitives like C#. So it has access to int, float, string, character, etc. And you can see that this was returned in the interactive console on the side. And F# has no return statements. The return is implicit based on the last evaluated expression. So when I highlighted this and ran just this line, that was the last run expression, and I loaded it to memory here. So if I execute it as well, or if I call it here, it's loaded, it'll return the same. Now that I've assigned this, this will never change. There's a special keyword in F# in which you can declare something as mutable, and I'm not even going to do it because it's bad practice in functional programming. You don't, once you've assigned a value or associated a value name, you don't change that value. Everything is immutable. And here's another one. So there you have a float, and that type was inferred based on that 3.5, and the same with string. We know that's a string. So if I run all of these, those are all returned in interactive console. So with functional, there's a lot of recursion, and you see a lot of lists. And we'll get more into that in the coding demo. Lists are separated not by commas like in C# but by semicolons. Additionally, there's no semicolons at the end of expressions like in C#. Everything is white space limited like a language Python. So this list is literally just 2, 3, 4. Run that, there's the return value here. If I want to add 1 to this list, I cannot just do it, I guess I probably could, but you won't see a list dot, add 1, like you would in a different language. You would create a new list, and this is kind of a list concatenation. You see syntax like that in Python, in which it will append 1 to list A. So if I run this code here, we'll see the values 1, 2, 3, and 4. This expression here creates a list from -5 to 0 inclusive. And then it concatenates list B and list A onto them. So we have -5, -4, -3, list up to 0. And then we have list B, which was 1 prepended on top of list A, followed by list A. Just some fancy list syntax, so hopefully the coding demo will also make more sense. In addition to the let binding, also applies to functions. And functions are just values in F#. So if I wanted to write a function in which I evaluate or pull even values from a list, I might do it like this. I assign the value of evens that accepts a parameter of list. And then here's the white space delimiter, so this is inside the scope of this function or this declaration. And then here's an actual function. So let is even accepts a parameter of x equal to x mod 2 equals 0. The equal sign in F# is essentially equal. And then it will apply we've declared this function inside the scope of evens. Do a list filter is even, so it'll apply is even on that list filter to list. If I were to write this in C#, it might look something like this. So if I apply evens to list C, we can see the output, and then it will only return the even values in that list. Right there. That's a very simple example of an F# function. But what you see commonly in F# are called pipes and lambdas. So we'll start with pipes. A pipe is just passing the output of one function to another one. So I declare the is-even function again. So let is even, as we saw in the previous code block, accepts a parameter of x and returns x if x mod 2 is equal to 0. We can effectively do exactly the same thing as the evens function with this syntax as well. So evens piped takes the 1 to n. I specified n equals 10 up here, so this will construct a list of length 10 and apply a list filter to this is-even function. So I will put that into memory. This just about, I had in loaded into memory, and the reason it returned this was because I declared this as a value rather than a function like this. So now if I run evens piped, it shows the return type rather than values. So I can call evens piped as a function with a list of 1 to n, and it will return the evens from 1 up to that value, 2, 4, 6, 8, 10. And so this is the pipe notation. So it takes the output of 1 to n and pipes it to this expression here. So lambda functions in F# are equivalent to Python, except it says the word fun, which is kind of awesome, rather than lambda, which the first time I saw that was scary, being 19 and learning how to program. Again, this is the same, this functional equivalent on in there somewhere, evens piped or just evens. So this expression will modify it to accept a parameter of list rather than just run it. We'll take that list as passed to the function and then do list filter. And here's the anonymous function that again returns x if x mod 2 is equivalent to 0. So when we call evens lambda with 1 up to n, it'll return, I didn't load it, we'll return the same list of 5 values. That was the briefest introduction I could think to introduce you all to F# syntax. Anyone have questions? Yeah?
I think you have a word there. In even pipe, you're not using list, you're using 1 to n.
Yes. Oh, you're right. Absolutely. Thank you. Thanks. Good call. And we can test that out. With evens piped, we pass that 1 to 20, and that should return a length 10. questions? Comments? Typos? Nothing? I was going to load an air horn sound on my phone, but I thought that might be a little obnoxious. Y'all are kind of quiet. Okay. So, empty screen, we're going to make it play Blackjack. I was going to program pokers, but I don't know how to play. So we're going to do Blackjack. Let's define the requirements. I think this is good practice in terms of writing any script you know what you're doing, just go off the rails real quick. Speaking from experience. So the first thing you need to play a game of Blackjack is you want to shuffle a deck. You want to be able to draw cards. You need to be able to calculate hand values. Does everyone know how to play Blackjack? I should have started with that. Does anyone not know how to play Blackjack? I'll explain how to play Blackjack. So you have a player and a dealer, however many players you want. And every card is worth face value, with Jack, Queen, King being 10, and an Ace being 11 or 1. The objective is to say it is close to 21 without going over. An Ace is either an 11 or a 1, whatever gets the player closer, again without going over, that changes depending on the cards in your hand. If you go over, you lose. So if it's 22 and the dealer is at 15, even though you're technically closer to 21, you still lose, and the house wins. The house always wins. That's a fun game. So, what was that?
Price is Right, showcase your.
Absolutely, yeah, yes. So with the calculate hand value, all cards are worth their face value, and except an Ace is worth either an 11 or 1, whatever gets the player closer to 21 without busting. Busting is going over. Insider bingo that I'm not really that privy to. All right, so then we got.
Dealer will hold on 17?
What was that?
Dealer will hold on 17?
Yes. Dealer will hold on 17. So if the dealer has 17, they're not going to hit. But if they have 16, they hit. Or they draw a card. So we initialize the game state, and then we play the game, and we need to determine the winner. Those are steps we're going to walk through. So the first thing is we need to get a shuffled deck. But this screen doesn't even know what a deck is. And it doesn't even know what a card is. It doesn't know what a suit is, doesn't know what a crank is, so we're starting from nothing. First thing we're going to do is we're going to open the system, just so we have access to some utility functions and whatever else. And then we're going to declare a type of suit. A type is essentially an enum in C#. So we can have clubs, or we can have diamonds, or we can have hearts, or we can have spades. This is called a union type, and they have choices. The vertical bar is basically this vertical separator is an or, essentially. So if I write this in C#, it would look like this. So that's half of the card. We also need the rank. So, oh gosh, I should have copied this already. Okay, so then we got rank. We have another union, and then we need a card. So we're going to declare another type in which we compose these two. And we'll assign a suit is equal to a type suit, and a rank is equal to a type of rank. And this probably looks very similar to a C# class because it is. This is a record class, a record type. You're fine. Next thing we gotta do is we gotta create a deck. Oh gosh, I should have copied these. So we need to declare a list of all suits, which is equal to clubs or diamonds, not diagnostic. Oh gosh. Hearts. Spades.
It's good when we turn, get most of the pilot off.
This is already a mess problem. That's gonna be
You're actually doing quite well for typing.
Thank you.
I could not do that.
I've actually read the script out like 3 times on the big screen just to make sure. So thank you. Yeah. So then we got to create a deck. So we have the list of all of our suits and all of our ranks. And this is, to me, indistinguishable from Python. So we're going to instantiate a deck. So we put let deck and then start a new list. So for suit in all suits. The only difference is we have this fancy do word. And then we're going to do a nested for loop, so for rank in all ranks do, and then we're going to yield a new card with suit equal to suit and rank equal to rank. And that is our list of cards. Any questions on that? Or does that look pretty familiar to everyone? So I'll show you that it works just for fun. There's our deck of cards on the right. Isn't that fun? But it's not shuffled.
Consumption is hard.
That's right.
So are enums like the underlying values or integers in F sharp?
No.
It's like C sharp or what is it?
I don't know, because I have a function in here a little bit later where I have to do a match with the enum to return the int type or the string type. So I actually don't think it's really either.
They are enums. If you do IL-SPY, you compile F sharp to a DLL and then do IL-SPY on it, you'll see the C sharp is generated. And those union types are just straight enums. If you have extra attributes on them, then it's creating a discriminated union, which generates a lot more code than just an enum. It's quite interesting, the union types. There's 2 different union types, and this one is just enumeration.
So it'll say just hearts or clubs under the.
It'll be like what you showed, the enum code at the top. It'll be like that, yeah. The C sharp is underneath.
Oh, okay.
Yeah, it literally, for that type of a union, it would be generated.
Thank you.
I think it's just F sharp is more protective against trying to access signatures and whatever. So you will be able to do something special.
Well, I think that's a lot nicer because, like, I always get annoyed with the fact that enums are integers. Usually I just want to treat them like a enum, think about underlying value or try to convert it to a string and all that.
I learned something. Thank you for both. Oh, thank you. So now we have a deck, but we don't have a shuffle deck. And if you're playing Blackjack with an unshuffled deck, that would be so boring, but I would probably win every time. So maybe it's okay, but that's not what our requirement says. We need a shuffled deck. So the next step is a guide write function to shuffle the deck. This will accept 1 parameter of deck. And we're going to do something that looks a little bit like ink. So we're going to make a new random, and random.next is just going to generate a random integer. So now that we declare that, we're going to pipe deck into a list.sort by, and then use a lambda function. We don't care whatever it's passing, we're just going to do random.next. And that shuffles the deck. It's pretty nifty. That's what it looked like in C sharp. Basically the same, but with a fun little pipe. So I want to prove to y'all that's going to work. So shuffled decks, shuffle deck with deck, and let. Sweet. So we have 4, and then we have a 9, and then we have a 6. I think that's shuffled. So we can knock out one of our requirements. Okay. Any questions? Perfect. Okay, I'll just keep going. So the next thing we have to do is we have to be able to draw a card. How are we gonna do that? Oh, gosh. There we go. So we're making another function. Everything's a function. It's kind of like that. Is this Stephen King with the turtles, like the turtles all the way down? Yeah, it's a functions all the way down. So draw a card, it's a function that's going to accept deck as a parameter. And this is a tuple when you have a comma, because lists are separated by semicolons, but having the comma in there, there's a tuple. So we're going to have a card in our remaining that will be returned, because when we draw the card out of the deck, we don't just want that card to magically operate back into the deck. It needs to still get that out there. And we're going to set that with list head of deck. So this is going to take the first element of the list, and then we're going to take the tail. So this is kind of like the car and the counter list, if you're familiar with lists or scheme. And then we're just going to return those. Card remaining. Oh gosh. So left card, and I don't care about deck right now. Shuffle deck with deck, and then we'll check the card out. Oh. Oh no.
Shuffle.
Oh, yeah. Whoops. Okay. We're gonna have to shuffle deck, and then this to draw card was the wrong method with the shuffled deck. There we go. Sweet. There's our card. Got 9 clubs. That's fun. Who cares? But we'll make it. But regardless, got one for our card. It's awesome. What if we want to print the card out? So rather than look at this like object notation, what if we just want a string representation? So it's like instead of this kind of messy JSON-looking thing, it would just say 9C. Let's try a helper method for that, which will actually matter. For now. So we'll declare another function with print card, and we're going to declare 2 functions. We're going to do suit to string, and this will accept the suit. And then this is called a match statement. A match is just a fancy switch statement, like in C#. It's just, hey, take suits and check against these conditions. And then we have the vertical bar separator. So if suit is equal to clubs, return a C. If suit is equal to diamonds, return a D. If suit is, that, not an arrow for the return. If it's hearts, return an H. If it's spades, return an S. And then we're going to sprintf the suit. Sprintf is a little different than printf because that sprintf is what returns a string value from this function. And these print strings are kind of fun in F# because it like type checks. It's more like C++ probably, whichever like one line in my life, so please don't quote me on that. But the percent %s is a string versus this is an integer, etc. So we know that will be we pass like suit to string. And this will accept the parameter card. Sorry, jumping around with card dot suit. We know this is going to return a string. And because this is accepting an object rather than some primitive in the .NET world, we're going to specify the type to be a type card. Because an integer or a string isn't going to have some like suit field on it, for lack of better words. Any questions on that? Okay, super. I forgot to mention, I'm so sorry. Here's the C# for the draw card. It's remarkably similar. Good y'all want to see that. Yes,
Is remaining basically a new dash, so you can't change zero or minus?
remaining. Yes, that's exactly correct, yeah. Because the remaining is returned from that draw card. And so when I call draw card, it needs to be assigned to two values, any card and remaining deck, or like deck after draw or whatever. And then that creates a new thing because all values are immutable.
So remaining is not shuffled.
Correct. It's new.
The list is a linked list, and what doing the head is popping the first one off, and then remaining is pointing to the remainder of the list. So it's pointing. So that's how the list stays immutable. Is you just keep on popping the head off. So a list of 10 items, a list of 9 items, and 8 items, and 7, because you just keep on popping the head off. That's what it is underneath the cover. So that's why when you did up above, you concatenate it to the front because you had to keep it still a list.
One of the things when I first started doing this was I'm like, well, wait, you're making a copy of the thing, and it's not. You're just moving that node pointer one spot forward, and so that place in memory remains constant, and you don't lose any processing time. You're just moving that pointer to a different place in memory.
That's clever. Learn something again. Thank you. Please keep bringing these up because I learned something too. So this really just returns a pointer. This list.head and this list.tail of the original list. Is that right?
So sorry, say again.
No, sorry, I just want to make sure I understand. So the list.head and the list.tail, that returns a pointer.
The list head is an actual item.
List tail.
And the list tails up the pointer to the beginning of the list, which is the remainder of the.
Thank you. Okay, so we have half the print card. Next thing we're going to do is we need to print the actual value. And this has a lot of typing, which I had before thought actually copy paste. So this would be ring to string. We'll accept a ring, and then we have match there. You guys don't have to watch me type it. You're welcome.
You sprint at the bottom, that's what you want, print F, right?
No, I want to return the value.
So that's print F.
It brings it to the stream. So it's just kind of like you see this.
Interesting.
Yeah.
Okay, gotcha.
And the last line is the implied return. The last line of the function.
Yes. So why I don't want to print it is because if I call, print to card, I'm not going to see that output on the console, I think. But it'll be assigned to the value. So if I have like the card string is equal to, I have card up there, so I'm going to do print card of card. And we're not actually going to see that value until I guess it's there. But it assigns that to this. So that's what the sprintf does, where I think if I take this off and then run this again, the card string is now just a unit, which is basically just F# nonsense for nothing.
Like a void.
Yeah.
Yeah.
I like nonsense. It's all nonsense, like why? So this is the return value. Cool. Okay, so we can print the card out, so we can see the card, so we know what we're doing, kind of, and then we can draw the card, we have a shuffle deck. We should probably be able to get the value of the card. So if I have a king, like who cares, how do I know it's a 10? That's next up, because that would be a prerequisite for this requirement of calculating the end value. I have to know what I'm calculating. So we're going to write another match statement with the function that accepts a rank as parameter. So this function we're calling let rank value. That will take a rank, which is the enum type declared. Also, I'm going crazy with the pointer or I'm scrolling. Please call that out because I can get kind of frantic with that. But again, the ranks are this type, enum type. So that's going to be the parameter. And then we are going to match the rank with. And I'm not going to type that. So if the rank it receives is a 2, it returns a 2 integer. And aces here are 11. Does anyone have questions on these match statements? Or F sharp switch statements?
Is your ace big one?
Yeah.
coming?
Yes.
Okay.
Squares.
Sorry.
Cheese.
Jumping the gun.
So, right, but we're defaulting it to 11. We'll write the adjustment in the calculate count. So now that we have the rank value, we can print the card out. We have the prerequisites for the calculate hand value, which is our next requirement.
I do have a quick question on the switch statement.
Yeah,
Is there a default return?
I don't think so. That's a great question.
I think if you apply, you
You can do pipe underscore, and then it would catch any,
return.
it would catch any remaining.
Oh, gotcha.
In this case, it's telling you that they're all, the reason why there's a warning there is because all of them have been used.
So we don't need to worry about that. Yeah.
So unlike C#, if you're doing a matching and you're missing some elements, it's going to give you a warning that you're missing elements to try to protect you from running into a runtime error situation. And if you commented out one of those ones up above, then rank will give a squiggly underneath it, usually telling you that. Yeah. And you can turn that into an error, that way you know you're not missing any.
Will the underscore count for that?
The underscore, yeah, it will count for that.
So it's able to see, hey, use everything in this type, so you're good,
Right.
but otherwise you need the control.
One of the motivations of using F# is it protects you more than C# does. In this case, it won't let you create a match without all of the expressions matched.
It gets rid of some of the boilerplate, right? It's verbose.
We're going to calculate the hand value because I don't have anything intelligent to ask about it. So calculate hand value is going to accept a parameter of cards. And this is functional, so we're going to use a lot of recursion, which used to scare me until I learned functional programming. I didn't really understand recursion until I learned lists. So it's more intuitive in F# in my opinion. So rec is the magic keyword for recursive in F#. So we're going to write a recursive helper function called calculate or calc value that is scoped inside of this let calculate value. And right now we're not going to worry about the aces. So it's just going to take parameters of cards and total. And we're going to do another match. And then we're going to write our base case. So if the cards is an empty list, we're just going to return the total. Otherwise, we're going to start our recursive stuff. And so we're going to take the card and the rest, and then pass that into a different condition before we hit our recursive call. So first thing we need to do is we need to grab the value of the card. So this notation, as we were chatting about earlier with the pointers and stuff, this is going to be the first element popped off the list, and then this is going to be the rest of the list. So this is like, list of 0 and list of, the rest. I think it would be 1 inclusive. If you're at Python, I think. So let card value equal to the rank value of the card.rank, which was this method just about here. So if it's a 2, it's going to return a 2. That's the string. And then we're going to calculate the value with and pass the rest as cards and the total plus the card value. Value, so that's what's going to do everything. It's very simple in here. If we wanted to write that in F#, maybe, or C#, apologies, we might do something like this. So we would new up our total to 0, do it for each loop, grab the card value, plus equal the card value, and then return. These will do the same thing. This is just the iterative flavor, and this is the functional recursive fancy flavor. So I'm going to call this helper function with the card passed to the function, and then set the starting total to 0. So if we pass, so I'll prove to y'all that works. So we're not going to shuffle the deck. We're just going to take the deck which is not shuffled. Card 1. Draw a card. Deck. And we know that the draw card method, the function signature, returns a card and a list. So then we have the deck after draw. And then we're going to grab card 2. And then I don't care about the deck after card 2. Withdraw card of the deck after the draw, so we know that card 1 is gone. And then I'm going to propose a hand, which will be equal to card 1 and card 2. And again, this is the non-shuffled deck, so we know this is a 2 and a 3, so our total should be 5. And then we will calculate the hand value of that. Oh gosh, no. Of that hand.
Oh, it's not helpful.
So there's that value, 5. Okay, so we have to calculate the hand value without aces. That's great. Because what if, instead of drawing these cards, I could do card 1 equal to a suit and pairs of heart, rank of ace, a little bit of king, and queen, card 2, card 3. So the problem here is that this is a perfect hand in blackjack. This is a 21, because this is a 10, this is a 10. You know, this could be an 11, but it should be a 1, because the 1 gets you closer to 21 without busting. But when we call that calculate hand, with those values, it returns 31. So we need to adjust for that ace. So that's cool. Makes our life hard. But in the requirements, we do have that all cards reversed or face value or kind of part 1. So I just want to check that off the list because, you know, this feels good to do. So how can we make life harder? What if we have to write the equivalent of this C# function? So instead of keeping track of the total, just the total, we're going to keep track of the total and the aces. And then we'll do the same thing. We grab the card value and add that to the total. But if the card rank is an ace, we have to keep track of that. And then we'll adjust the total. So if the total is over 21, which means we busted, but we have an ace, then we can take 10 off the total, so we're not busted, and then say, okay, we're cool, we count for 1 ace, and then return the total. Does this logic make sense? Sick. Okay. So what we're going to do is we can write more recursion. But one other thing we should keep track of in this is we should keep track of the aces. Because when we're looking, and I'll just put that. Oh, where am I? I'll just put that up there so it's a little bit more visible. We have to keep track of the aces. So it needs to have one other parameter in the recursive call. So we need an additional parameter of 0 aces to start. And then we call this with aces in this case scenario. This is still just going to return zeros because we're not modifying aces and we're not checking for it. So we have the card value. If the card rank is equivalent to ace, then we're going to make this call with aces plus 1. So it's still going to calculate it as 31, but now we have 1 ace as that gram. Oh. Otherwise, it's the same. Okay, but that doesn't help us because now we have 31, but we know we have 1 ace. So so what, who cares, I guess. So we need to write another one. So we're ready to adjust for aces. I don't care about the cards. I already have the total and the number of aces, and that's all I need to know. So we know if the total is greater than 21, and we have an ace, then we adjust for aces with total minus 10, because ace was set to a value of 11, and it can be 11 or 1, and ace is minus 1. Because, hey, we just adjusted for one card. Otherwise, we just return the total. So I need the else. So calculate value now returns total, and I need to modify that. So it also returns the aces. So this is going to return a tuple. So we'll set total and aces to calculate value. Why is this angry? Oh, that was angry. Okay. And then we will return adjust for aces with total and aces. So the first thing it's going to do is going to calculate that 31. But then it's going to say, hey, I'm not done yet, and it's going to adjust. And total will be 31, and aces will be 1. So it'll hit this condition. Set total equal to 21, aces equal to 0. Make a recursive call. We know that the total is not greater than 21, and also we don't have any aces, so we'll just return the 21. Let's run it and see if it works. So our hand that we're going to calculate this value is ace, king, queen. Previously it was returning 31, and hey, look at that. We got a 21 on the screen. Perfect hand. That's fun. Any questions? Okay, well, I'm going to knock off that requirement. So one other thing just to make this pretty is we probably should be able to print the hand. So rather than just seeing, this hand list, basically this nastiness on the screen, we should just see like A, H, and part of Q of H and K of H, just because conciseness. So let's try a quick method called print hand that accepts the name of whoever's playing, whether that's the dealer or the player, and their values. And then we're going to build a string. We're going to call that hand string. And in here, we're going to take the hand, pipe it. We already have a print card method that returns a string, but that has print F niftiness. So we're just going to map that using that list utility, print card. We know the pipe is what passes, hand, so you can think that that's like there. And then we'll do a string recap. And here, we're not going to return it, so we're just going to print it. Print Fn. So there'll be like players, hands, and then the values there. The hand string. So our hand is that, these values up here. So instead of seeing this, I call print hand, we should just see a name. There was no return, so obviously it just says unit, which is equivalent to void. There we go, player's hands. So it's kind of nice, and it'll clean up the console noise if we're playing this in a console. That wasn't a requirement, but it was fun. So the next requirement is initialize game state. And this is going to accept a unit, because if we don't have anything to initialize the game, like we don't need anything to initialize the game, so we're just not going to have it accepted. And we could do this, basically card 1 in the deck after card, and do that 4 times to start the game up for the dealer and the player, but I'd rather just write a method and call it draw 2 to start the game. So draw 2 will take a deck, this parameter, and we'll have let card 1 and then it will return a tuple, deck 2. So we're just taking a deck, we draw card 1. This is the deck after we draw that first card, and then we draw card 2. And then this is the deck after we draw card 2. Then we return card 1 and card 2 in the deck after the second draw in the draw 2 method. So we don't want to play with an unshuffled deck, so we're going to call the shuffle deck method with the deck that we newed up on line 4 or whatever. And then we're going to deal the player hand and have the deck after the player draw equal to draw 2 with the shuffled deck. Oh gosh. Then instead of calling this player hand, we'll call it dealer hand, and then deck after dealer. We need to make sure that the cards are not duplicated across the hands, so they have to be removed from the original deck, but because, as we mentioned earlier, all values are immutable, so we need that new deck, which would be deck after player. So now we have the dealer hand and the player hand, and the deck after the dealer takes their draw. We just need to return. So we will return the player hand, the dealer hand, and the deck after the dealer has taken the draw. Questions, comments, concerns? Cross off another requirement. Awesome. Okay, now we gotta play the game. Because this is all very good and well, but what are we gonna do with this? Probably nothing, but we need to play. We're gonna call this Jack Black. Keep it spicy. So the first thing we need is we need our hands and the deck. We'll call it deck after dealer for fun. And that's the end of the game. We pass that unit because we're starting from nothing. So let's just get the balance back. And then we have this fun print hand method. So we're going to use that. And we'll print the player hand. Oh gosh. So now we can see we have hands, but we're still not playing the game yet. We're going to start at the dealer turn because that's a little bit less interactive. We're just going to automate it, and it's going to hit, like you said, it's going to hit on 16. On 17 it stays. So if you're going to write this in C#, it would look something like this. We're going to calculate the hand value of the given hand. If the hand value is 16 or less than 17, we're going to draw a card, print out their hand, like what they drew, add it to the hand, and then make a call again. So this is another recursive call. But if this condition is not met, then it's just going to return the hand in the deck. And it's actually a lot more concise in F#. So So this is going to accept the hand and the deck. First thing we need to do is we need to calculate that hand value with their hand. And so, if the hand value is less than 17, then we're essentially in this if statement. So we'll have them draw a card with that deck. Print that the dealer drew. Print card method. Slipping into C chart. All right. This is not a method call in that chart. Don't do that. Otherwise, we're going to return a hand in the deck. Oh, forgot the call. So here's the dealer turn. We're going to pre-pint that card onto the hand and the remaining deck. It's still mad at me. Okay.
You haven't returned anything from the function, the Jack Black function.
Oh, thank you.
Is it intentionally Jack Black instead of Blackjack?
No. Yes. So we can call it the dealer turn. With the dealer hand and the deck after dealer. The player would typically play first, but just to keep it simple, we're going to play the dealer first. And then we're going to call Jack Black. Yes, correct, absolutely correct. Thank you. Else hand deck, okay. I just want to see what the deal. So instead of printing out this whole deck, let's just see the hands. There we go. So dealer drew a bunch of cards. I guess we could just call the print hand function. That could have been a better idea. And hands. Okay. Why is that not? Dealer drew this, dealer drew that. I don't know why this doesn't seem to want to call.
No, that's
Okay.
You have dealer, it's 17. Yeah, it's up to 17.
Here we go. Okay. So dealer would have busted there if he got 30. That's fine. I should add a requirement that says dealer should play. So we can cross it off. Woo! Okay, player. It's going to look real similar. So if we were to write this in C#, it would look like, not like that. It would look like this. It's basically the same thing, but it has to be more annoying because we have to deal with I/O so the player can interact with the console. So we'll have if the hand value is less than 21, then they can hit if they choose to. If they type in an S, they're going to stay, and so it'll just return the hand in the deck. If they type in H, they're going to hit, so we'll draw a card out into the hand and then make a recursive call, ask them if they want to hit again. And the default is invalid choice, try again. And the player typically plays first, so I'm going to put it up. So the first thing, again, it accepts the hand and the deck as the parameters. And so we need to calculate the hand value to check if they can even hit. So we'll print the player hand value. And here's the I in the string formatting with hand value. And if the hand value is less than 21, then we can hit. So we give them a choice. If you want to hit or stand. Put that there. So we do another match. It's all functions, it's all match statements. So we match the console read line. This does have that C#-ish method using, I guess, the space. So then we have another switch statement. So if it's a stay, then we just return the hand of the deck. If it's a hit, then we're going to draw a card. So we have the let card and remaining deck equals the return value draw card. Then we're going to tell them what they drew. So this isn't blind mark, that's a different game.
Card. Your read line doesn't have a S, right?
Oh,
Maybe that's a little.
that's it. Oh gosh, what am I doing?
Remaining is,
Oh gosh, I agree, what?
remaining, you have to switch to letters, so three and
Oh,
remaining.
thank you. I see. Remaining. Oh gosh, oh. There, wow, yikes, thank you. Oh. It's just getting worse.
Still doing great. No worries.
I'm not sweating at all up here, it's fine. So then we got the default. Jonathan, you pointed this out earlier, this one's, it's your line. So then, invalid choice. We need to print it. Try again. And then we call it again. Layer, turn, and done. I guess this quite doesn't need the comma. No, it does need a comma. But it's mad anyway.
To pull this on. Is it consistent, the types that you're returning across all those? Play return.
I think so, because this one returns a play return, and this one returns a play return, but hand and deck.
Perhaps parentheses around hand and deck then?
Let's try that. It got me hooked for like half a second there.
So close.
So close.
Tom's right.
This expression was expected to have type unit match on width. So it's not a unit. Oh. It's because there's not an else. Woo! Okay, wow, that would have ruined my whole night, guys. Okay.
You made it.
We did it. We got there. Okay, so now the deal is proven the player can play. So we already have player hands there, so we need final player hand. So we have the final decks of the player turn with their initial hand, and then they're going to hit with the deck after the dealer has taken their draws. So then we have the final dealer hand, and I don't care whatever that deck is. And with the final deck, they're going to do their turns. Okay, so now the dealer can play, the player can play. Now we have to determine the winner. Cross out the requirement. We're actually cross out too. That's great. We're almost there, guys. Determine winner. So if I was going to write this in C#, I'm not even sure this is that helpful because the font has to be really big. Sorry about that. Let's get these out here. We'd probably do something like this, a bunch of if-else's. At least this is how I would do it. So we would accept the parameters of the player score and the dealer score. If the player score is less than 21, or greater than 21, then they bust and they lose. House wins. If the dealer busts, then the player wins. Otherwise, we're going to check and see, okay, so if the player didn't bust, the dealer didn't bust, whatever score is greater is who wins, and if they're the same, it's a tie. So we just need to write that in F#. Super fun. So we're writing a method called determine winner. And that's going to accept, like that C#, the player and the dealer as parameters. And so we'll match, play with another match statement. Player greater than 21 and the dealer greater than 21. So we're going to match a tuple of booleans with, if the player is greater than 21, we don't care about anything else, the player loses, the house wins. So that is what, so these are in order here. So this returns player busts, dealer wins. We'll capitalize dealer. If it's the inverse, so if this did not evaluate the true, but the dealer busts, then the dealer loses and the player wins. But what if either busted? Both of these are set to false because the player is not greater than 21 and the dealer is not greater than 21. So we're doing another match statement. I love match statements. F# loves them. So we're going to pass the dealer and the player to that match with, and we don't really care about that, so we're just going to do an if statement, so or a win statement. So when the player is greater than the dealer score, the player wins. So when the player is less than the dealer and neither busted, the dealer wins. The only other thing that happens is it's a tie. So now, all we have to do is call determine winner with the final player hand and the final dealer hand. Calculate value of those. And there we have Blackjack.
Yeah.
So let's play. Control-Alt-C, clear the console out. So I loaded that method into memory and I'm just going to call the method. Okay, so I have an 18. Should we hit it, or should we say?
It's a soft 18, go for it.
It's a soft hit, all right.
Hammer.
Player, you drew Jack. Wait, what the heck?
He didn't activate after the draw.
You're right. What did I do?
What did I not write?
Still 18.
You drew a draft. That's
Yeah.
10.
Yeah.
I missed something. I missed something?
No,
Oh,
that's
it's
right,
right.
it's correct.
Right. Yeah, that's right.
That's
You
all
are
right.
at 18.
Oh, it's okay.
Yes.
Let's hit again.
Hit it again.
Hit it again. Okay. Woo. Player bust, dealer wins. That was dumb move hitting on 18, huh?
On a hard occasion.
Yeah, no. That's what you mean by soft 18. Thank you. I don't play blackjack very often.
Oh, thinking, because I was paying attention.
Okay, so I have a 15. Hit. All right, let's hit. So is that a soft? Or is that a say? Okay.
Yeah.
Got blackjack. That's it. I'll stop talking now. Thank you all for listening. Thank you for coming to my demonstration.
Great work.
All this will be available if y'all want to, they might have a console.
Got a question?
Oh. Yeah, no. Okay. Hi. Yes, Jonathan, I'm so sorry. Hi.
Is your next presentation going to be on maintainable F sharp, where you break this out into 500 classes and abstractions instead of a dependency injection framework and refactor services for calculating the hand values and all of that?
I don't think I'm allowed back in the .NET user refactor
No,
tonight.
It's not a C# users group, it's a .NET users group.
Exact opposite.
I'm being like kind of sarcastic, but like, what about abstractions and F sharp and do we need them?
That's such a good question. I don't think I know enough to answer that. I think the answer is probably, I was reading the documentation to like modules, and then I got frustrated because the file ordering actually matters and stuff, and I was like, yeah, that's it is, just do a straight file. So the answer is probably, but I don't know. Because I don't
F sharp is basically a dual for that language, so you showed us the functional part of it, but it also has object-oriented, which is very similar to this, to C#, and you can look at the object-oriented, code of F sharp. It will be very similar to C#.
When you're asking about abstractions, are you asking like an interface?
Yeah, interfaces and like if I want to calculate hand value, but I want to be able to pass in different implementations of that calculation for that service, do I create an interface for that or?
So if you passed in something that had the same function signature as what was expecting, so the abstraction is at the functional level instead of the class level?
Yeah.
So it's implicit.
So we don't need interfaces is what you're saying?
No, it'd be functions. And by passing in functions, you automatically get the interface segregation principle because you're not combining things in interfaces and not alone.
So that's another example of like not needing the boilerplate.
There's some other interesting things that you didn't have time to get to, but there could be a part 2 or part 3 or.
Can you do part 2?
I could do part 2. Does somebody want to put up with me on part 2?
Keep recruiting your speakers.
I would do that.
Any other questions for Sam?